Assalamualaikum warahmatullahi wabarakatuh. Hello everyone and welcome to our video. Today we will be discussing descriptive statistics, measures of relative standing.
In this video, we will explain about percentiles, T-scores, Z-scores, and CEEB scores in a simple and easy to understand way.
But before we begin, let us introduce ourselves. My name is Anissa Tiruniar. My student ID number is 089.
My name is Shifa Nadira and my student ID number is 091.
My name is Zahra Kamila Ramadhani and my student ID number is 092.
Without any further ado, let's get started.
Measures of relative standing. What are measures of relative standing? Measures of relative standing are statistical tools used to describe how a particular value compares to the rest of the data set. Instead of just looking at raw numbers, these measures help us understand how one value compares to others. For example, imagine you take a test and get a score of 85 out of 100. So this number alone doesn't tell you much. Maybe you might wonder, did I do better or worse than most students? Or am I in the top 10% of the class? Or how many students scored higher or lower than me? So to answer these questions, we use measures of relative standing. These are statistical tools that help us determine the position of a specific value within a dataset. There are several types of measures of relative standing, including percentiles, Z-scores, T-scores, and CEEB scores. Let us start with percentiles. What are percentiles? Percentiles are a way to compare a value to the rest of the data. They divide the data into 100 equal parts, while quartiles divide the data into only 4 equal parts. Percentiles measure position from the bottom, meaning they tell us what percentage of the data falls below a certain value. They are commonly used to determine rank or relative standing in a group. So for example, in test scores or graduation rankings, percentiles help show how well someone did compared to others. There are two definitions of a percentile that I will explain. First definition, a percentile tells us what percent of the data falls at or below a certain value. This means it includes both the values that are lower and those that are equal to the given number. Now, let's look at the formula for finding the percentile rank of a score. The formula is B plus 0.5 times E divided by N, then multiplied by 100, where B is the number of scores below the given value, E is the number of scores equal to the given value, and then N is the total number of scores. For example, let's say Jason graduated 25th out of 150 students. So this means that there are 125 students ranked below him. So we use the percentile rank formula. B plus 0.5 times E divided by N, then multiplied by 100. Where B is the number of students ranked below Jason, 125. E is the number of students with the same rank as Jason, 1, since no one else is ranked 25th. And then N is the total number of students, 150. So the formula will be as follows: 125 plus 0.5 times 1 divided by 150, then multiplied by 100. First, calculate inside the parentheses. 125 plus 0.5 times 1 equals 125 plus 0.5, which equals 125.5. Now, divide by the total number of students. 125.5 divided by 150 equals 0.836. And then multiply by 100 to get the percentile rank. 0.836 multiplied by 100 equals 83.6. Since percentile ranks are usually rounded to the nearest whole number, Jason's percentile rank is 84. Jason is in the 84th percentile, which means he performed better than 84% of the students in his class. In other words, only 16% of the students ranked higher than him. Next, second definition. A percentile tells us what percent of the data falls strictly below a certain value. This means it only includes the lower values, not those that are equal. So the formula is B divided by N, then multiplied by 100, where B is the number of students ranked below Jason, 125, and then N is the total number of students, 150. So the formula will be as follows: 125 divided by 150, then multiplied by 100. We first calculate 125 divided by 150 equals 0.83. Now we multiply 0.83 by 100 equals 83. So Jason is in the 83rd percentile, meaning he performed better than 83% of the students in his class.
Alright, now I will show and explain to you the examples of percentiles using formula and visualization. The first one is using formula. Here is the formula. B is the number of values that are smaller than the searched value. E is the number of values that are equal to the search value. N is total number of the data in the set. Here is the data: 50, 65, 70, 72, 72, 78, 80, 82, 84, 84, 85, 86, 88, 88, 90, 94, 96, 96, 98, 98, and 99. The E or value 84 exists twice. In the B, there are 8 values below 84, and the total data N is 20. Now we will calculate it. 8 plus 0.5 times 2 equals 9. 9 divided by 20 equals 0.45, then multiplied by 100. The final result is 45%. Now we go to example using visualization. In this method, we just need to sort the data, divide the same numbers into two groups, and then count the number of numbers below the value we are looking for. The grade data is 50, 65, 70, 72, 72, 78, 80, 82, 84, 84, 85, 86, 88, 88, 90, 94, 96, 98, 98, and 99. Alright, here is the formula. Now I will explain to you what is X and N. X is the specific score being analyzed. In this case, the specific score is 84, and then N is the total number of scores or data points in the dataset. In this case, is 20. So, the value for which we want to calculate the percentile is 84. Total number of data N is 20. The data consists of 20 values ranging from 50 to 99. We want to calculate the percentile rank of the value 84. Since there are two values equal to 84, one is assigned to the group below 84 and the other one is in a group above 84. Therefore, there are 9 values below 84. First, we divide the number of scores below 84 by the total number of data points. 9 divided by 20 equals 0.44. Next, 0.44 times 100 equals 45. Therefore, the score of 84 is added 45 percentile. Alright, that's all for the examples. Now we will move to z-scores. Z-score is a statistical measure that describes how far a value is from the mean in standard deviation units. Z-scores are used to compare values in different distributions or understand the position of a value relative to a distribution. For example, a student took a math test and the scores of all students are distributed as follows: 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. Here is the formula. X is the value for which we want to calculate the z-scores. And then the second is the average or mean of the data, and S is standard deviation of the data. Alright, let's take a look at the example. Z equals 85 minus 70, then the result is divided by 10. 85 minus 70 equals 15, then 15 divided by 10 equals 1.5. So, Z equals 1.5. The z-score is 1.5, which means the student scored 1.5 is standard deviation above the mean. In practical terms, the student performed better than the majority of students.
Next, t-score. T-score, on the other hand, it is normally distributed and is standardized score. The t-score distribution have a mean of 50 and a standard deviation of 10. So that's the difference between z-score and t-score. Z-score has a mean of 0 and a standard deviation of 1. And t-score has a mean of 50 and a standard deviation of 10. So z-score can be converted into t-score by following equation adding 50 plus the z-score multiplied by 10. Then, when we use the t-score, when the sample size is less than 30 and when the population standard deviation is unknown. It is commonly used this t-score. Next, CEEB score. CEEB scores were developed by the College Entrance Examination Board for the Scholastic Aptitude Test or SAT. Because z-score can be positive or negative, z was multiplied by 100 and 500 was added. This results in a CEB score mean of 500 and a standard deviation of 100. SAT score are now compared to the standardized score of the 1941 test group, resulting in a relative number distribution that is comparable across year. Last but not least, what is Stanton score? Stanton score are standardized score designed to give a nice or a convenient measure ranking for 1 to 9 on a standardized assessment. Now, by definition, the average will be 5. Within a 9 score will be fixed, amount similar to STEM score. What about if we have certain numbers? Of course, Stanton score over STEM score is that you do have a whole numbers. Average 5 is exactly average for 9 scores, whereas 5.5 is average STEM scores, which can be a little bit difficult to convey to people who are unfamiliar with this. Consequently, if you would like to really simple average measure, Stanton may be a better option.
In conclusion, measures of relative standing like percentiles, t-scores, z-scores, and CEEB scores help us understand how a value compares to the rest of a dataset.
These concepts are widely used in statistics and real-life application and also making data interpretation more meaningful.
And we hope this video helped clarify these topics. Thank you for watching and see you next time.
Wassalamualaikum warahmatullahi wabarakatuh.